Hi Sam. Yeah, sure. I don't mind explaining a lot, but just, in most cases when I do that, people leave. So that's why I completely stopped with it. But the idea is quite simple. Well, it's actually not simple at all. Let me see. I want to generate prime numbers in the following way. I have an object, and the object generates all integers that are not divisible by a prime, some given prime. And all primes below that. So for example, these numbers here, they are not divisible by 2, 3, or 5. And they are generated by an object that, well, can do that. And because they are between 7 squared and 11 squared, the only composite numbers that will be generated have a factor of 7 in it. And the rest is prime. So while this object is generating its numbers, it just checks if it is divisible by 7. And actually it doesn't even check that. It knows in advance what the next one will be. So it checks if it is equal to 77, and if that's the case, then it calculates 7 times 13 and waits till it is equal to 91, and then it calculates 7 times 17 and waits until it is equal to 119, and everything else is prime. And it just adds these things, like prime, 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 until we hit 11 square. And then we create the next object, which then does exactly the same thing, but then for all the primes between all integers between 11 squared and 13 squared that are not divisible by 2, 3, 5, or 7, and therefore I will only have a composite that has a factor of 11 in it, which I can calculate in advance, and so on. And then the way that I know these numbers is because they are these numbers, and these numbers are these numbers, which is just a repeat of the previous one, where I skip certain things. For example, so I try 4, I just ask this one 4 plus 4 plus 2 plus 4 plus 2. And then I calculate those. So actually it's not really true that it generates 59 at once. It generates 55 in between. But then it sees that 55 is divisible by 11. Actually, again, I calculate that in advance, so I know it must be a factor of 5. And I know that 11 is the first prime after 7. So I generate 53, and then when I encounter 55, I skip it. And then we add 2, and then we add 4, and we add 2, and we add 4, and so on. And then every time we get something that is equal to the next expected failure, which means that it is divisible by 5, then I skip that, and that's the way I generate these things. But since each object does it the same way, I can just stack them all on top of the very beginning, which is as easy as you can imagine. And then the result is that it generates primes. I don't understand your next question. Is the intent of the formulaic derivation for use or application to chance random games involving no? I'm just doing it for fun. I wrote it in the description of the first time I started with the primes yesterday or 2 days ago, I think. When I was 12, I wrote a program, my first program that I ever wrote on paper, because we didn't have a computer yet. That was calculating prime numbers, and I used a method that then people told me was called the sieve of Eratosthenes, and that is that annoyed me because I never heard of the guy, and it was my own invention, and then someone else's name is the truth. I didn't even get credits for it. Not even while I was 12. And I lost a tournament. Because then there was a tournament for some luck reason. I don't know, half a year later or a year later maybe. We had to write a program that did that. So I sent him my program, and some adult walked away with the first prize because he was taught about the sieve of Eratosthenes. And he cheated a little bit. So his was a little bit faster. And then I, as a kid who had invented it myself, got the second prize. But well, I wasn't. So I've been frustrated about that ever since. So I've always been interested in trying to find a better way to generate prime numbers. And that's the only reason that I'm doing this. Because it's, well, kind of interesting, I guess. Anyway, we get 2, 3, and 5, and then it fails. So I have something to do. I think that the object that is generating this 6, well, it has to be this one, right? So it just doesn't detect that the 6 that it generates is equal to 2 times 3. And it should be able to do that because it knows about the 2. So that is the question. Does it know about 2? I think so. I can see that here actually. Must be this one. And it knows about 2 because of this 2. Wait, I have to look at primes. So one is waiting for 9 already. Why would I? So I produce my 6 while I'm waiting for 9. Oh wait, the 9 is a square. Yeah. I just need to find my 2. Where's my 2? Fill index, last prime, window. This one, there, P. So P is equal to 2, so I just should check that and skip the 6. It's just hard to find my way inside this program already. Okay, so loss prime is incremented with the next gap of window 2. And then if that equals expected failure, it's a different expected failure, but why would I wait for 2 things at the same time? It's kind of silly. Probably should reuse the same variable for it. And then I need to know here if it is a square or not. Yeah. That's the failure index. Doesn't make much sense, I have to say. If you ask me, that's just equal to pi plus 1. So here also I'm just setting the previous failure index plus 1. So every time I create a new sieve, the failure index is 1 larger. And the same holds for pi, I think. So every time we create a sieve, I'm using the previous pi plus 1, so they both are incremented by 1 every time. New sieve. Yeah, pi plus 1. See? So I should repurpose that for something else and use pi plus 1 here. I have absolutely no idea what to set this to yet. Let's set it to 1, random. And then expected failure now is no longer depending on failure index. So here also failure index, well, it's pi plus 1, but I know what that is. So I might as well use 1, and I know what 1 is, that's 2, so I might as well set it to 4. Maybe that's also not correct. Nope. I'm going to call this thing pi squared. Well, actually, it's not pi squared, it's the next prime squared. Yeah, well, let's type it in full. Next prime squared. Did I forget something? Yes, I've got an underscore. Can change the comment. I don't even have a comment. The square of the prime after pi. After p, I mean. So that would be 13 and then squared, right? 169. So let's see if we can understand that by looking at troop. Yep. So I'm using this object here, the object between those horizontal lines. So this is one object. I'm using this object to understand what everything means, because here the numbers are different enough to recognize them. And then you can see that it will generate 169, which is a failure because that equals 13 squared. So we just store that. And that 13 squared means that for this object, p underscore equals 11, which is this one. Maybe I should add that here. I'm starting to lose track every time. So p is 11 in this case. No manual entry. Oh, dude, what? Caps lock? Caps lock. Why? Okay, so this one has PS. What's happening here? Undo. PS7. PS5. This one is PS3. And this one is PS2. And I know it's not a prime number, but then this one is PS1. So this one doesn't exist, apparently. Thing above this. This one is default constructed. And that one is not constructed at all. Maybe I should just delete it. Let me see, +1, just have you started one. Yeah. I don't think it adds a lot, so let's just delete it. This is the beginning. Let's fill everything in. I think I'm going to add more and more information to this layout here. So much that I should not remove it anymore. Move troop to readme. And then we can look at the very first primes. Primes is a thing that that's just a vector. It's the first sieve, which has 2 windows. It has a last prime as well. Yeah, this is the sieve. So that's a default constructed one, so I can copy that. And P equals 1, as you can see. So this corresponds to that thing. Yeah, so P0, that's 0 then. Well, I can put that there as well, I guess. Say I have that. Let me put the windows somewhere. Window. Last prime. It's the last prime of this object. Maybe I should move it down, like that. Fill index and expected failure. So expected failure. What I renamed that. Let's move that there. Window 1. So I have here pseudo lead. Do I have that here as well? Let me see. If I go down. I think the lead here is so unclear. This now we begin with the value corresponding. Yeah, it's a start. It's not a gap. So we begin with the value before adding the first gap. So I need to know what this corresponds to. And I deleted that. Very smart. Now I can see that here. That's the 2. So this is 2. 3, 4, 5, 6. That's what they correspond to. And then the thing before the 2, so before I add this 1 to get the 2, is 1. And if I want to do, I really have to change this, I think, into the horizontal line all the way up there. And then this 1 here is the start of the first window, I think. No, not really. It's the start of the second window. Or is it? I don't know anymore. I think it's the start of the first window of the previous object. So actually I don't have a window 1 here. What? No. Window 1 is being used down here. So it must be window 2. But it isn't. No, window 2 is this one. So I think window... Yeah, okay. Well, this is the end result. So I might as well have window 2 point here. So I think that I should forget about window 1 here, maybe. Let's put window 1 above it. And then window 2 as that start. That one is this start. Well, why the hell is last 2? This is wrong. A wrong value. Doesn't make any sense. Well, I can make it point to that too, I guess. Yeah, actually, no, yeah. Well, it's kind of the last value, right? I mean, this is the first thing that we're going to return. This 2, and then after that we have the brace. So after that, the stuff repeats. So maybe it's correct even. So this 2 here is. And if I want to point to it, maybe I should put it down here. Instead, so now that is the 1, and then this 2 here is that one, that 2. I don't know where to put window 1 yet. This is after construction, so head begins with well, being equal to start. It's the same thing. I'm trying to generate prime numbers in a smart way. So maybe I should make it point to that as well. I don't know. Nah. I'll keep it on. Head is somewhere between start and last. These are constants. Last prime. Okay, last prime is this one here. And then I have a failure index and expected failure. Well, clearly this is the expected failure. What is this one doing here? Beats me. What is this one doing here? Nothing, right? I don't know where that one comes from. Let's delete it. So arrow, that would be expected failure, which is 4. Or is it? No, it's not. And I was thinking that that I didn't understand why I had expected failure here in the first place, because I renamed it. I just renamed it to next prime squared. Oh, I just looking at the old output. Let's run it again. Yeah, that's better. So now it's called next prime squared is 4. Naming things is very important. Where's my 4? Yeah. So I renamed this thing to next prime squared. What is the current prime then? So this is the current prime. It's not a prime, but okay. The next prime is then 2. And then that 2 squared gives 4. Everyone happy. Which makes you wonder, why shouldn't I just start at 1 and 2 and then shift prime 1 further? Might be an idea. I'm not using P at all yet. But okay, let's keep it like this for now. And then we are still having the failure index, whatever that is there, whatever that is. And the expected failure. And we don't have an expected failure because we have a nothing here. So I think that the expected failure is listing these failures here, and that's just nothing till nothing. There's just nothing here. So it's definitely not 4. I don't know, nothing. Irrelevant, I guess. And I don't know what that is. I mean, I don't care, because it's nothing anyway. Now, with that out of the way, we can, I guess, see that at this point, when I see this square, I'm going to create a new sieve. So maybe I should move my horizontal line to right there. So from here to there. Let's just do that. And I made another change. I moved this corresponding list to below there. I think I have to reverse these things. So I want to see that comes from there, and then this, maybe like that. It's not very clear yet. It will be more clear, more down below. Maybe like that, because let's do it like this at the moment. And then we have PI is going to be 1 more, so that's 1. And P is going to be, maybe I should use an equal sign here as well. It's not how I printed it, but well. P is 2. Although that more belonged to, you know, hey, this is the new object. So maybe I should put that below here. It's kind of a weird place to have it here. I think I'm moving the other one all the way up there. Comma is unnecessary. And then we do the same thing here. Let's remove the spaces, maybe. Because now it's going over my arrow. Not another room. Okay, let's put it on 2 different lines. Maybe the whole index is not really necessary, or I should do just, I want to know the prime probably, and I can put the index behind it. It's a shorter version. So then here we get p underscore equals 2, and that belongs to index 1. That fits. That will be that one. And then we get what else do we have? Last prime. I guess that should be 4. It's very hard to get this correctly, but it's important, I think, to have this ASCII art. Otherwise, I cannot get my code written. I think I'm sure we're talking about this one now. Wait a minute. Oh, this is sieve. No, what? Oh, that's the same sieve. I need, we're talking about this one, PY. What? Next prime squared is 9, is that correct? Oh, yes, that's correct. That's this one. Okay, so I'm trying to put this information in here now. Let me just put this here. Okay, so the p equals 2 is here, and the p index is there. And the window I do last, and then the last prime is initialized to 5. That does not make any sense whatsoever. I still have to print that. Maybe I print this. This is being printed, I think, after generating the 5. I need it to be printed immediately after construction, because that's what I want to show you. Yeah, see. Currently I'm printing it there after already having called next. But it's inside next, not in the other next. Next. Yeah, we do a new. But yeah, there's little to print. Primes changed, but how do I print primes immediately after constructing a new sieve? That doesn't make any sense. Wait a minute. Don't have that. Yeah, it's bullshit. I just want to print a new sieve, I think. Might as well print that from the constructor then. I'm going to print it here. Standard cout. Created this. And then after calling p in this loop, that it's not necessarily creating new sieves. So yeah, I still have to still have to print primes, I think. So we print the prime, and then I print the next prime number, and then I print the content of primes. Do I seriously have 2 primes? That's not good. That's confusing. Oh no, I don't. That's local primes. Well, actually I do. I think I have a prime somewhere. As a vector. Yeah, primes underscore. Let's rename the other one, because it's confusing. See here I call it primes, but okay, that's only here. Here we call it primes. Yeah, I'm passing it as primes. I'm going to rename the primes class to something else, because it's just a bit confusing. This is more like a prime generator. How shall I call that? Generator. Why wouldn't I call it prime generator? So primes. It should work. Percentage substitutes primes becomes prime generator, and then this thing now called null generator. I don't want to print too much generator. I am going to rename this then here as well. Prime generator. Right. So created sieve, and then the generator looks like this, which contains one sieve. Actually a pointer to a sieve, but I just printed, so this is the same thing as that one. And I already have that in there. So the generator changes from, yeah, only the last prime is changed, and for the rest nothing. So the first prime is 2, and we print that, and then last prime has been changed to 2, because that was the last prime that we printed. Every time we print a prime, last prime is being changed to that. So 5, last prime is that. If we print 6, even though it is not prime, then last prime is 6. So that works. And then here, halfway, we have a new sieve that is being created. And that information belongs to the next prime index, which means that it is the next sieve. Maybe I should do created sieve, but okay, anything that I create is a sieve, so it's kind of workable, I guess. So let's edit a readme and add all that information then to this one. That information. It's a mess. Let's delete what they already have. They created, I believe. The braces we don't need. And P is 2 already have. These two we already have. The window 1 goes somewhere and I don't know where, so let's leave that here. And the window 2 goes here, which is below below this. Okay, we have this. That's the previous ones, and then below there, because that's the values that we actually point to. Yeah, let's put that here then. Put it in the same column. And then my start is now 4, which is actually the thing before this one. So this is 1 plus 1 is 2. And here, though, we have 4 plus 1 is 5, right? So maybe I should not repeat that. Instead, we now call it 4. There's my arrow up here. Now this line is extra and it's not very important yet. I think I really want to have it somewhere else, so let's put it there for now. So start is 4 and then we add 1 and then we get 5. And if you add 1 again, you get 6 and then 7 and then 8 and then 9, and that's what you learned in middle school, right? Maybe even before that. And head is again equal to start, and last is equal to 3, which is highly confusing because you would expect 5. Shall I change it into 5? I think I'm currently ignoring it. So if I set it to 5, I don't have to ignore it, which is maybe better. Then how do I calculate a 5? The 5 is just start plus 1. I don't know. Where does the 1 come from? I think the 1 is the sum. The sum of all gaps, or multiplication of 1 times all previous primes. So the previous prime index and then that thing and then summed up. No, multiplied. Yeah, well, who cares, I would say. Let's just force it to be 5. I guess it depends a bit on the next one. I want to see what the next one is doing. Okay, what else do we have? This line. The next prime squared equals 9, which is this info. The last prime is 4. Okay, I'm gonna go ahead and change this into the hint that it should be equal. And the failure index, add that on another line. And we have an expected failure here. It's got completely lost in my output. Did I delete that? Oh yeah, it's not printed at all. We're going to need that, so that's another thing. No, I don't have an expected failure yet, but it's going to be this one here, 2 times 3. So this is going to be the first expected failure. So after initialization, we need to have an expected failure of 6. And I still don't know what failure index has to be then. And that comes from this. I think failure index. Maybe I don't need a failure index anymore. I mean, the failure index is 3 here, and then the 4, which is simply the normal output that we get here. Even though the 4 here is ignored, it's still being generated by this object. And that's what we need. So that means that we have another window here. And You know, I just don't see if it comes from this one or from this one. Can fill it in later. I think I'm going to delete it now. No filler index for now. Don't know where to put it. An empty line. I don't need an empty line there. Let's put the window on more or less the same place as the other one. So there. I'll do, not sure what it refers to yet. And then I think I morphed this one into the same format as the one above that. Yes. So while constructing window 2, I want the last here to be at least one larger than start. Because, yeah, I'm going to make that a 5. And then we are done, I think, with this object. Yeah. Let me see, maybe I should already put this here. I think if I change that into a 5, that I can delete this line, right? So that's the whole idea. So the test is no longer necessary then. But where is that initialized damage? Lost? Oh, here, lost. Is that it? Yeah. Just being passed to sieve in the constructor. Somewhere. And well, window 2, right? So it's a constructor of window 2. Yeah. It's just one of them. This one. Excuse me. I think this formula is basically correct, but I'm just going to force it to be something else. If, let's say, pi equals 1, I think it was, then as if I have access to that. No, that's not working. Might as well do it inside window 2 then. Huh? Okay, what the hell? The start value was... We're talking about this one. So if the start value is 4, I'm going to force it at 5. Or maybe even more general. Nah, let's do a test. So, sieve window. Yeah. Okay, created, generate 2 and 3, create a new sieve, generate 5, and then we crash, because that is again not less than last. Yeah, it's because we reach 5. That means that it has to repeat. So I'm having a window that reached its end. In this case 5. And then we have to repeat, or actually switch to the other window. Now, let me think about how to do that. Let's assert that it is less than or equal. It should definitely never ever be larger than last. And then I can do a test here if I had reached last. Then we have to do something special. Otherwise you do what we already did. Being determining the gap. So maybe I should just something like that. Yeah, this is a non-trivial, completely non-trivial. I don't know what to do yet here. Let's look at this. So here's an overview of the sieve window idea. We have the list of gaps starting at 2, so 2, 4, 2, 4, and so on until here, and then it has to repeat. But that grows so large that I don't want to allocate memory for it, while we are only working in the small part usually. But then in two different parts at the same time. So I need to create two windows. For example, this part is one window, and then this part is the other window. But if either of those windows, if head becomes equal to last, then the window is full. Or if it is this window, then it could be that we are all the way up till there. So this is completely full. And then what I should do is not get the gap from, I don't know, from here. There's nothing here. Although I know that this is what I need. You know, after this, then it should just continue here. You see the 221, 223, and so on, right? But this is the same as that. It just starts repeating. So if I come here, what I really want is just read the first gap of the other window. And that is the exact same thing here. If this window comes to the end and I need the next gap, we already returned 8 and I need the next gap. Well, the next gap is 6. And that happens to be the first gap of the other window. And we can just read that because, well, if we then reach the end of that, then we have reached the end twice, and then we have everything. And we can just read everything, so rotating around. So a single window actually gets kind of, gets to keep track of two windows. Well, at least the position where it is in the window, and then when you reach the end, the position where it is in an existing window. Now I'm wondering if that is just a matter of reading it then, or that we can overtake it. I'm not sure. I mean, even if I start reading here at the beginning, the head of that window is still pointing there. So I need another pointer, apparently. What an annoying thing. I'm really concerned about that one. The one is overtaking the other. Like, suppose this one is at 173, like it is now, and this one gets to the end, and we keep calling next gap on this one for some reason, not on that window. Then we start reading here, so we return 127, and then until we got here as well. And then if we overtake it, this one wasn't generated yet. If that can happen, then the code has to be a lot more difficult than when that cannot happen. Yeah, it would really help if I knew how these things are gobbled up, in what order. I think we call window 1, sorry, we call window 2 next, repeatedly, and then we stop with that, and then we start calling window 1 next, repeatedly, and we never stop with that. I think that's what's happening. For example, let's say we start with this object here. Then these numbers or these gaps belong to these numbers, which are not divisible by 2 and 3. That's the thing, of course. It's actually these numbers. So these are not divisible by 2, 3, and 5. And that would be window 2 and calls to the previous one. Yep. Window 2 is done until the square, and then we create the next object, and that object then needs to generate these numbers, which is what comes after that. No. These numbers here, which also are not divisible by 2, 3, and 5, just like these. But this one starts as 19. So we go from 53 to 121, and then we start at 19, and then we go forever, probably. I mean, not in this case, because it is going to repeat before we get there, I think. Or is that nonsensical? Oh, right. Yeah. It is, actually, but that's the case where last is less than start. So let's just assume that that we continue forever-ish, and then we get all the way up till 53, till we hit the end of that. And then we should just start rereading these, of course. Or however it works. But at least that's the order. First we do window 2 without touching window 1 at all. And then we do window 1. And that might then run into window 2 or not. I think that's how it works. Wait, I was looking at, here. So in this case, I would generate all of these. And that goes on until 11 squared. Slightly confused here. 11 squared is this. No, so it goes on till 13 squared, right? 13 squared, 169. That's there. Yeah. Bad example. It's already at 173. Just in case that is the case, that reduces significantly. So I think what happens is we do 6, 4, 6, 2, 4, 6, 2, 6, 4, 2, which is 13 squared. And then we go to the next object. And the next object starts here. So that then does 2, 4, 2, 4, and so on and so on. Until it reaches 8. And then it starts reading these because it already did that. So it continues then with 6, 4, 6 above because it already exists. And then it has to start generating them again. So then these are again generated. So what I could do is assume that we'll never reach the end of this window, because I think I'm making it large enough, right? Oh, that's not even sure as well. No, this ends at, well, yeah, this ends at that plus a lot. So eventually it's going to mean, eventually for larger primes at least, so that it is the case for 11. This is going to be huge, and therefore we stay within one window, which is of course not the case then in the beginning. But okay. Theoretically, we would not reach the end here. And then when I do reach the end here, I just have to start reading stuff at the beginning. It's not that easy, is it? Do I ever switch back again to this one? No. It's a tough design, this 2 windows in a rotating thing. Yeah. Head is just up till where we have generated it. So head starts at start and then only grows until it becomes equal to last. That's a life cycle of head. And then through that we have to read it, always starting at the beginning. So maybe I should call that tail. And then as long as tail is less than head, we can just read. And if tail hits head, and I want to read from tail, then I have to bump head. and then I can read from till again. So if head is already equal to last and till reaches last, then I'm not interested in that it also equals head. I just go to the beginning again, but I'm not going to the beginning of this window, I'm going to the beginning of the other window. So I do switch window and reset the tail of that window. And that is allowed because the tail in itself is only used by one algorithm at a time. And we do first one window and then the other one. So the window itself, apart from the switching, just needs another pointer, a tail. And I need two member functions basically. One that advances tail and one that advances head. And then of course it does the right thing when we hit when tail hits head or last and or when head hits last. I think I need a break, so going to watch another movie, I think. Continue with this tomorrow. I hope. I mean, if I continue later, then it's gonna be working in the middle of the night again. Yeah. Just don't feel much like continuing at the moment. I'm going to need a tail. Tail. Okay, let's put a tail here. Let me see. Tail can never be passed ahead. So this is the second window. It also has a head and start. And then normally I would just start in this window producing stuff until we hit the end. And then start reading tail here, which begins at the beginning. So that could be yeah, that can only be tail can only be unequal start then if head here is already equal to last. I'll just draw the tail in at start. Yep, and let's rename the current next to, call it next gap. Let's say next head or read head. I think a read head. Let's see, next gap. So read head here. And we have a retail. I must be able to reset the tail to the start as well. So do a void reset tail, which I only need when I really start wrapping around, because I'm going to initialize. Oh, wait a minute. Value. Yeah, I have to store the values as well. Zero or -1. I think 0, which means that I have to make it point to the first gap. Yeah. So tell read head. Next cap. To I don't know which is which here. Next prime. Advance window 2. So I don't know which window this is, and if I switch window, I want to switch member as well. Very very nice. Oh. So we begin with window 2 and reading head until some point. You see that correctly? Yeah. So until some point, and then we want to continue with reading window 1, reading the tail again until some point, and then we want to read window 2 again, but now reading the tail. And then from that moment on we will only read the tail, but then alternating windows depending on. I think I should create window 2 maybe with a pointer to window 1. It's an extra indirection, but I don't see how I can speed it up. So normally I would have, say, a single pointer and then directly read from the right thing, but I don't even know which member function to call. Maybe use a lambda. But I want to change the lambda every time I switch between the windows. Man. I think so. I'm doing too much premature optimization, I guess. Thinking about stuff that only has to do with optimization. Let's just code it. Okay, I'm going to implement just everything as a window to the next gap, right? I mean, that reads nicely here. But that means that window 2 must know about window 1 and vice versa. Then what do we get? So I'm reading from... no. Event happens, reset that, switch to that, read that. If we hit that, then it takes care of that until we hit that. Then another, that's another event, and then we switch back to that. Hitting it. Call that, yeah, so. Why not call tail immediately? Retail. Hey, that's an idea. Retail until retail until that point or that point, and then we go there, and then a switch out would work, and then I have to call reset till always, but it's not a problem. And then, or we go there, reset till, also retail. Or, wait a minute, what was it? Yeah, we at the end, so that was already read. It's at the end there, reset retail. I don't need a read head. I just going to retail all the way. Tail, which is kind of silly to call it tail now. Okay. It's not clear. It is not clear. And now I have to implement this, so we can skip that one. And now we jump to the top. Do I not have a 1? Next gap 1. And then I'm going to re-implement that. Let's gap 2. Okay, let's get rid of this. And the retail, I don't need a read head. So I just always call retail now. And the idea is then that internally we switch window. So I need the thing to have a pointer to the other window. Or a reference. No, don't know what to do here. Yeah, it's mind-boggling. I don't think retail is the right name, you know. Not really, really. Well, this is the only next cap I have, so might as well call it next cap then. And that is on previous sieve, which is a sieve. So I have to add here a next cap, and that returns just a prime gap, I guess. Yeah, prime gap type. And here, nobody knows, I'll just try to compile it. Gap is 1. Does it now compile? Nope. No matching function for call to int and a null pointer. I forgot a thing. Yeah, the other window. Well, I might as well, even though we won't use it. Yeah, that compiles, and then I don't know. Yeah, we even get 5235. Returning 1 does all wonders. But yeah, I'm going to watch a movie and I don't know, continue tomorrow. I think really, it's getting too difficult, too late. Or I can just continue, damn it. Because, okay, I'm not done yet. Retail. Should read from window 2 initially. Actually, it should just read from the tail. Okay, we have a gap, and we're going to return the gap. And if tail is less than head, sorry, I can't, oh, I don't have an index for my head. Just a value. Okay, single window. No. We are going to store the gaps. Yeah, you would say I don't need to store head. It's just the last element in gaps. And if gaps is empty, then heads is virtually equal to start. No, that's nonsense. I'm storing gaps. Sorry, I'm storing gaps. It's +2. +2 is in gaps. And head, I need head. But this index here is true. That is gap size -1. What else do we have? I think this is about it. I have a start, a head, a tail, last, and gaps. Start, a head, last, tail, gaps. Oh, we have pointers, yeah. To the previous sieve and to the other window. Okay. If not a previous sieve, return 1. That probably should still hold. And then if tail is less than gap size, right? Then we just have the value already. Nothing needs to be updated except tail itself. And I just want to return the gap, so yeah. return gaps tail plus plus. If it's not less than, it's equal. If the thing is full, that would be the case if head equals lost. Soft keys generating prime numbers. If head equals lost, we are full, and then that's a special case. Maybe let's do the non-special case first. That's also a special case actually, but a little bit less special. So in this case I want to read the tail, but the tail is at the end. So what I do is we generate a new head, and there is a room for a new head. So update head, and then this is the case. So I can just do that one again. But before we do that, you have to do a gaps pushback. The new gap. And I have to calculate a new head, I think. Let's say, what's the type of head again? Integer. So I calculate a new head, then eventually we can do head becomes new head. And the gap here then is maybe we should do pushback gap and then also return it. Seems more logical. Prime gap type gap is the new head minus the old head. Suppose head is on 151. Now we do head becomes 157 here, that's the next head. Gap is 157, 151 is 6. And then we do head becomes 157 and we push back 6 and return that. Which means that previously we had this situation, which is always the case. and tail was equal to head, I guess. Tail was equal to gap size -1. That is not correct. This is gap size -1, but then that is true. Huh? If tail standard. I guess tail can be 1 larger than head. Tail could be 7. And then if tail equals 6 here, then we can still return 2 because we have that. And otherwise, and at the moment we return that 2, then tail's incremented to be equal to 7. So then the next time, 7 is no longer less than size. Size is 7. Yeah, so it is equal. 7 is 7. And head is less than last here. Do we get here? And then we do the 157 thing. Calculate the gap. Store and return the 6. But because we returned it, tail must be 8 now, right? Just have to be, yeah, otherwise I'm going to return the 6 again. So I have to increment tail either way. I don't like it. Yeah, whatever. I don't like it. I mean, it's just something that I should do here. So I should redefine tail to something that is 1 less. Which means that tail must be initialized to -1 instead of what I said before. I'm just going to do it tail to the empty case here. Initialize to -1. Yeah. I might want to see these values, so these are just not there yet. And the -1 is confusing me, so I'm just pointing this to 7 already. So now till is the index that was returned last. What I should probably add to the as a comment somewhere. So if it is like this, and the +4 was already returned, we need to return +6 now. Which means that we are going to increment till, oops, before comparing it with size. What the hell? No, keep pressing caps lock. Caps lock. Okay, so till is always incremented, and if it then it's still less than size, then we can use it as an index into caps for obvious reasons, and otherwise it's obviously equal to the size at that point. And then we already have incremented it, so I can just return it without having to increment it again here. So as long head is equal less than last, then there is room to generate a new one. Yeah, and how are we going to do that? Well, the usual way, you just increment it with 1. And so head +1. I think that works. And if head is not less than last, then obviously it should be equal to. Already had that assert. Yeah, above here. Right, so then head equals last, and the thing is full, and tail is at the end, and therefore we have to go to the beginning of the other window. So I have to switch I have to switch window here. This is probably what I need to do up there. But I don't have a next gap yet, or didn't implement it. Next gap is returning 1. Might as well call it then. Gap. If I start with a gap anyway, might as well do that. So it seems more logical. Now I think about it. Let's first make it a gap. And then it simply is incremented with the gap. Right, so what is happening here? Head equals last, the thing is full, we need to switch to the other side. Meaning I need the other window, which I think was C tags. I'll run it manually. Oh. I added I passed a line number. Yeah, auto window. Auto window is a reference, so I can call reset till on it. And then I wanted to start calling retail on that one. Which also should be called from that moment on. I think I need to pass the other window pointer, or the window pointer rather. So have a sieve window pointer reference window. And then we do, well, let's switch window like this. The window is auto window, which is of course ugly, so let's do it just like a pointer. Window is auto window, and then we do window underscore, no, window. Reset till and return window retail. Okay. And therefore, yes, other window must be a pointer now. Let's just pass a pointer here. And then we must pass a reference to that pointer to retail. It's a recursive reference passing. So this was all that. And then here we pass a reference to the window itself. But that must be a pointer. So we're working actually with the window pointer. Sorry, must be a member. Yep, and a member is the member of this class, and that is a sieve. So this sieve itself must now have a sieve window pointer called window, which is initialized with window 2. And that means that sieve may not be moved in memory because now it contains a pointer to itself. Uh-oh. Actually that's good because my sieves live in the on the heap. They're just new deleted. But just to be sure, I guess I should add a private sieve constructor move thing. Copying is also nonsense, now I think about it. If you add a copy constructor, then you don't have a move constructor. So if I add a copy constructor and then delete that, then it should be fine. Now what? Alright, I added this one. There's another constructor here. Same thing. Oh wait, must be window 2. Yeah. Probably, no, it feels more logical to pass pointers here. Let's pass pointers. Here as well. So the sieve constructor, sieve window constructor. Now it takes, oh, it already took a pointer. I don't know, try to compile this. Find all the compile errors. No compile errors. What the hell? crash. Still returning 235. I just can't get it to break. How did head get larger than lost? That's an interesting question. Oh, because I'm just blindly updating it. I'm not detecting at all when it becomes equal to lost. Well, actually, I'm not blindly updating it. If it is less than lost, I'm updating it. Are you telling me it's going from less than lost to larger than lost? Nope. Not there. Okay, time to run it in GDB. On this up. Nine and 5. Oh, right, I get it. Yeah, yep. Yeah, let's ignore that for now. Let's just concentrate on the fact that it turns 6 as being a prime. So we go to readme. And we go to the 6 here, and then we see that 6 should not have been returned because it equals to 6. And we should have had an expected failure equal to 6. I don't even have it defined yet. Expected failure. Let alone compare with it. And we're talking, I think we're talking about reading here from select basic six. No, this is just being returned. That's just in next prime or something. Nope. Just next, which calls next on sieve. I want to get rid of failure index because I have no idea if I'm going to use it. Next. Right, so we have to set expected failure to something sensible. And the first sensible thing to set it to is drum roll. I don't know, I have to look at README. Expected failure is 6. That is 2 times the next prime, where the 2 equals 2p. Right. So it's p times the next prime. That should be possible. I have even a prime index also. That's the one here. We can do that. So that is p. It is 1. Times the next prime is 2. So the expected failure is 2. Oh, shocking. No. 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 There's no expected failure here. There's nothing. Yeah, nothing. Okay, let's do that. Nothing. So that would be the one at the top. Nothing. Yeah, this one. In the very first one. Okay. Yeah. And then the next one is 2 times something. This is the default constructor thing, so that's nothing. So we have something here. Well, that then is equal to p times, well, the next prime. Now we return 4. How disappointing. Oh, that's because nothing is not nothing.
4. Nothing, which means x prime squared. And in this case, this is less than that one, so it does always happen first. Yay! It would be nice to replace it immediately after finding it with the next value, right? Can we do that? So here I'm going to have to skip it. Let's first skip the thing. How are we doing that? I think this. I'm absolutely not sure. Let's have a look at readme again. For example, if we hit the 6, then we just add another 1. And if we hit, let's say, way down, so we can understand what happens. If we hit the 77, we just added 4, and now we hit 77, so we want to add 2. And that's just the next thing, the next gap from wherever we got the +4 from. So I think that should work. We got the +4 here, and then the next one is the next one, right? So that's just going to be the 2 then here. That should work. But after doing that, I have to update my expected failure to become David. Yeah, really, I don't know, man. Just what I'm doing now. No, write something that generates prime numbers. Theoretically, you would say p times the next prime number, but that's not working. That is working actually. That is working for the first window, and this is the first window, isn't it? Okay, that's kind of scary. I think it's actually working. Bring back the expected value index, I would say. Why not? If it fails, then I want to see it fail, and I understand that much better. So I'm going to do times that, where I do expected failure index. And then let's say the next one, so ++. And then I need an expected failure index as well, which is then equal to pi plus 1 initially, which we use here. Okay, I'll just fill it in. Everyone sees what we are doing there. Dubious, I have to admit. Dubious. Expected failure index. It's probably an int. And then this is nothing. I don't care. Let's put it at 1. pi plus 1. Okay. Does it compile? Of course it compiles. Does it run? 2, 3, 5, 7. Ta-da! It took 2 hours, but now we have another prime. 7. Yeah, there is progress. At least 1 prime number per day. Super disappointed that it outputs 8 though. That didn't work at all. See, it didn't work. Damn it. No. It was not good. It's already wrong. Ugh. I mean, it went from 2 times 3 is detecting the 6 to 2 times 5, trying to detect the 10. And that should have been 2 times 4, I guess. So, yeah. Next prime number doesn't work there. And I think that it works after this. So you can make a special case just to get past this. Or not? What do you think? Should I just do it properly immediately? Or actually I want to use primes. I want to use the prime there because it's faster. I already have primes. What can we do about it? Okay, just a very, very ugly workaround here. So if expected failure equals 10, I think that should work. Then I'm going to set, nah, not really. I want it to be 8 then, and I want to just undo that one. So then the next time we do detect 8, and it's still not equal to 9, so we get here, and then we do again plus 1. Sorry, last prime plus whatever. I think it becomes 9 then. Yeah, so okay, now it becomes 9. Last prime is now 9. What was it last time then? No, whatever. And then we get expected failure is again, same thing, so it becomes 10 again. So we get here again. But this time last prime is 9. So now I can do if last prime equals 9, then expected failure is 9. Else that. So this is just this is what I call hacking. So you know what I understand the third word. It's also automatically ugly. And I'm curious what the result is, of course.
result is a total failure. Well, you skipped the 8. The 9 is still being printed, and then we get the quality of ChatGPT. Prime number 9, 10, 11, 12. Oh. Why is it printing 9? Do I really have to run through the debugger to understand that? Let's print 2 and 3. Where's my 3? 3 there. 5. We're getting closer. This is the 7. The generator now says we are at sieve is still at b equals 2. Probably. And okay, last prime is 7. I'm happy. Next prime squared 9, also good. It's not printing the. Okay, let's do that first then. And what else did I want to have printed? And I wanted to have a look at the README. The PS2 must be the one with 9, right? PS2 is the one with 6. Oh, and 9, yeah. Looks good to me, but we want to print expected failure and expected failure index, I guess. And I come after last prime. OS, expected failure is 8. Yeah, well, that's correct. Is it going straight to 9 then? Expected failure is 6, and then we go to 10, and I set it manually to 8, and then we go to 10 again, and I set it manually to 9. And we print 9. Why the hell are we printing 9? Did they update primes already? Yeah, I updated primes already. So what happens here? Last prime equals 8. Sorry, 6. And then we add 1, so now it is 7. And then we figure out that 8, then it becomes 8. I add this, now it is 9, I think. Prime equals 9, expected failure is 9. Oh yeah, that's gonna help. Okay, so it's already failing then. So instead of doing that, I should do whatever I should do after detecting that it is failing, and then that's true. So we have to do the same things there, which is super ugly. Why? I think that's better. Theoretically, expected failure should have, I don't think I need it, but let's set it to 9 anyway. The rest can stay as it is. I think so. And now we crash after the 7. Oh, had less than lost. Again. Interesting. Maybe one up. Head is 9 and lost is 5. Oh yeah, right, that. Oh yes, and I already said I understood that. And then I had to step through it to understand why it happened in the first place anyway. We're on some kind of sieve window. Start is 9. If you say so. Loss is 5. Caps is empty till -1. Yeah. Yep. Okay. Yeah. Absolutely. So let's set this 5 to something else. What shall I set it to? I think I have to set it to 11. Good. We'll look at the readme. Let's see, this is talking about, I think, this thing here. Oh, boom, 9, 11. 11 is the last one. Yep. To hack that one as well. For now-ish. Five, 7, 10. Yeah, of course, 10. I would output 10 as well. It's still doing the 10, 11, 12, 13, 14, etc. Where does this 10 come from? We have a created index 2, P is 3, start 3, head 3, last 9. Yeah, this one, 11. 9 till 11. Last prime is 9. So we have to add 2 to get... I'm adding 10 because I'm not adding 2. I'm adding 1, I mean. Expected failure is 3. Right, that doesn't feel right. Oh, it's index, sorry. Expected failure is 15. Yeah, looks very good. Prime square 25. So the one with squared, this when the square is 25, then the first value would be 15, it says here. Let's have a look if that is kind of what we expected. 25. So in this case, the first thing that fails should be 15. Yeah. Yeah, and at output 10, cannot really blame it, or even have it here. Should I detect it? 2 times 5, how silly is that? Yes, feels like I should, right? We're still here, we're still at +1. Last prime was 9, right? They set it to the square value, 9, and then I have to add 2, but I'm adding 1. And that's all nice and dandy, but then the expected value should have been set to 2 times 5. Why do I have here, you know, I'm supposed to be detecting 3 times something and not 2 times something. Here we're detecting 5 times something and then 7 times something. Oh, I didn't update these things yet. They're still in the old format. Loads and loads of work ahead. Okay, this comment is like way old. Let's remove it. Yeah, that's problematic. I think I should actually create this with an expected 2 times 5 problem. It's just confusing me. It's definitely confusing me a bit. This is again an exception. This is an exception, and then afterwards we'll never run into it again. I'll just add another exception, I guess. But it's starting to get old. The exceptions. Plus maybe 9 squared. Maybe we should test it. I could test it maybe, just one more. Now here's something equivalent going on. So this is not even the last one then. Would not be the last one. If I set last prime to 25 and I'm still adding 2, then we'll get 27, which is not 5 times something, but 3 times something. Feels like we need one more check after the square. Why? I don't like it. Why do I need to add 4 here? I need to add 4 because 27 is 3 to the power 3 even. I mean, it's like taunting me. Try to detect this without using factor 3. It's totally factor 3 thing. Cannot get around that. And the plus 4 here is literally, oh wait, the plus 4 is detected, yeah, that literally this. So it really has to be. (31 to the power 3 plus 12 is prime. Okay, yeah, I'm just interested in generating small prime numbers. The moment. I guess I have to, at the moment I create the next object, I could, no, I want to skip it immediately. To detect this, I can immediately calculate a 27 and then see that it fails. And then what? Then I have to then something. Yeah, I'm going to stop, guys. I mean, tomorrow, another fresh day. Getting tired, I guess.